Now the next topic that we will discuss is, let's say these are your two lines L1 and L2, and let's say these are your two bisectors B1 and B2. This is B1 and B2. Now we have already learned how to find the acute angled bisector and the obtuse angled bisector. The next type of question that we will discuss is, let's say we have a coordinate, we have a point P. Now the point P, wherever it lies, either it will lie close to B1, that is in the region where B1 is passing, bisector B1 is passing, or it might lie in a region where B2 is passing. Now we are interested in finding out the bisector in which P is lying. That is, if P is lying in the region where B1 is passing, we want to find the equation of B1, and if it is lying close to B2 in the region where B2 is passing, we want to find that bisector. So this is to find the angular bisector in which point P lies. Now the steps for this is, you will have two equations, a1x plus b1y plus c1 is 0, and L2 would be a2x plus b2y plus c2 is 0. Bring all the terms in both the equations to one side and substitute the coordinates of P. That is L1P. L1P means you have substituted the coordinates of P in the equation. Let the coordinates be alpha, beta. So let's say we are finding L1, that is we have substituted the coordinates of P in this equation, a1 alpha, b1 beta plus c1, and L2 is a2 alpha, b2 beta plus c2. Now we'll multiply these two values, a1 alpha, b1 beta plus c1 into a2 alpha plus b2 beta plus c2. We are only concerned with its sign. Now there are two cases. Either it will be positive or it will be negative. Now if it is positive, then with the positive sign we will solve the equations to get the bisector having P1. Or if the value is negative, with the negative sign we will solve the equation to get the bisector having P1. For example, let's say P is 0, 0. I want to know the bisector. We'll take the same question as we were doing. Let's say 12x plus 5y plus 4, 12x plus 5y plus 4 equals to 0, and 4x minus 3y plus 4 equals to 0. These were our two lines. We will have two bisectors. We want to find out the bisector which contains this point, that is the bisector in which 0, 0 lies. So what we will do, we will bring all the terms in the equation of lines to one side, which is already present. Now we'll substitute these values. So 12 into 0, 5 into 0 plus 4 into 4 into 0, 3 into 0 plus 4. What do we get? 4 4s are 16. That is positive. Therefore, while solving the equations for the bisectors, we will take positive sign. And this bisector will be the bisector in which 0, 0 lies. That is, the region in which this bisector will lie will also contain 0, 0. If the question says find a bisector in which this point does not lie, then in that case we'll again find the sign of this, and we'll now take the negative sign, because we don't want 0, 0. We want the bisector in which 0, 0 does not lie. So we'll take the sign opposite to what we are getting here to get the bisector which does not contain 0, 0. Okay. Now what we'll do, we'll take a question and solve all the cases now. Let's say we have a question. Let we have lines 3x plus 4y minus 1 is 0, and let's say 5x plus 12y plus 2 is 0. Now, first part, find the equations of the bisector. Now this is the easiest one. What we do is 3x plus 4y minus 1 upon square root of 3 square plus 4 square plus minus 5x plus 12y plus 2 upon 5 square plus 12 square. What do we get? 3x plus 4y minus 1 upon 5 is equal to plus minus 5x plus 12y plus 2 upon 13. We'll cross multiply. We get 39x plus 52y minus 13 is equal to plus minus 25x plus 60y plus 10. Now we'll solve one by one, taking positive and negative sign, and we'll get both the bisectors. 39x plus 52y minus 13 minus 25x minus 60y minus 10 is 0. We have taken the positive sign first. We get 14x and minus 8y minus 23 is 0. This is one of the bisector. The second one is when we take the negative sign. We have 39x plus 52y minus 13 minus 25x minus 60y minus 10. Everything is taken to the left side. We have 64x and then 112y and plus 3 is 0. This is the equation of the second bisector. This is part A. The second question is, find the obtuse angled bisector. Find the obtuse angled bisector. For this, what we do is, we find a1, a2 plus b1, b2. Whatever the sign it gives, we take that sign and solve the equation to get the obtuse angled bisector. What is a1, a2, b1, b2? 3x plus 4y minus 1 is 0. 5x plus 12y and plus 2 is 0. So what is a1? 3. What is b1? 4. What is a2? 5. What is b2? 12. What is a1, a2? 15. What is b1, b2? 48. And this is what? 63, which is positive. Therefore, we will take the positive sign between the equations and solve. So what was the positive sign output? This was the equation that we got when we took the positive sign. Therefore, this bisector is the obtuse angled bisector. 14x minus 8y minus 23 equals to 0 is the obtuse angled bisector. Similarly, if we want to find the acute angled, obviously the other one will be the acute angled bisector. This is the acute angled bisector. Now, let's take the third part. Find the bisector. Find the bisector which contains point, let's say 2, 1. So we want to find the bisector which contains this point. Okay. So what we do is, we substitute this value 2, 1 in the equations. Let's say this is 3 into 2 plus 4 into 1 minus 1. Bring all the terms to one side first. Into 5 into 2 plus 12 into 1 plus 2. This is 6 plus 4 minus 1. And this is 10 plus 12 plus 2. Obviously, this will be positive. So therefore, we'll take the positive sign and solve the equations. And what was the equation that we got when we took the positive sign? This was the equation that we got when we took the positive sign. Therefore, this is the equation. This is 14x minus 8y minus 23 is 0. Is the equation or the bisector which contains point 2, 1. And which is the bisector which does not contain 2, 1? Obviously the other one. 64x plus 112y plus 3 equals to 0 is the bisector which does not contain 0.2 comma 1. Now let's take one more question. Find whether origin lies in acute or obtuse angled bisector. And the equations are same. That was, what were the equations? 3x plus 4y minus 1, 3x plus 4y minus 1 was 0, and 5x plus 12y plus 2 was 0. I guess this was the equation. Yes. Now, we want to find whether origin lies in the acute angled or obtuse angled. Now, this is the point 0, 0. Therefore, what we do is substitute this value in the equations by bringing all the terms to one side first. 3 into 0, 4 into 0, minus 1, 0, 5 into 0, 12 into 0, plus 2. This is minus 1 into 2, which is minus 2. Now, minus 2 means negative sign. Therefore, we will have to take the negative sign. This will be 5, negative sign, while solving the equations to get the bisector. Now, this will be the bisector. This will be the bisector which contains, this is the bisector which contains the origin. This is the bisector which contains the origin. Now, we will also find A1, A2 plus B1, B2 to see which bisector is the obtuse angled bisector and which is the acute angled bisector. Therefore, what is A1? A1 3 hai, B1 is 4, A2 is 5 and B2 is 12. So, what is A1, A2? A1, A2 is what? 15, B1, B2 is 48, which is 63, and therefore it is positive. Therefore, we will have to take the positive sign to get the obtuse angled bisector. Take positive sign to get the obtuse angled bisector. Obtuse angled bisector. Therefore, we will have to take the negative sign to get the acute angled bisector. Acute angled bisector. And when we take the negative sign, we have the origin in it. Therefore, what does this tell you? It says that the origin lies in the acute angled bisector. Acute angled bisector. Because if we take the positive sign, we get the obtuse angled bisector, and we take the negative sign, we will get the acute angled bisector, and when we take the negative sign, we get the bisector which contains the origin. Therefore, the origin lies in the acute angled bisector.